We're going to start to look at ionic bonding. And when we look at our ionic bonding, we're actually going to look at your cation and your anion and that transfer of electrons. So just to show you visually what's going to happen before we actually start to lump these things together, we might have something like lithium. Lithium has one valence electron. And let's just pair this up with something real easy at the beginning, and we're going to pair it up with chlorine. Chlorine's a halogen. It has 7 valence electrons. So just to draw the Lewis dot structures here, what's going to happen is, before we said that this one valence electron was going to go away, never really said where it's going to go, but this one valence electron is actually going to transfer to something like chlorine. And when it transfers over to something like chlorine, it's actually going to create a bond. So when it creates that bond, lithium lost an electron, so that makes that side positively charged. Chlorine now has a full valence shell. It gained an electron. It has a negative charge. Opposites attract. They stick together. So when you have that transfer of electrons, you have your cation and you have your anion. With your cations and your anions, sometimes it takes more, sometimes it takes less. And I'll kind of go through that here in a few minutes. But as we look at these transfers of electrons, that's what's creating that chemical bond right here that's sticking together your cation and your anion. So as we look at your cations and your anions, we're going to put a cation with an anion, and when we put them together, you're going to do something called swap and drop. So in order to swap and drop, what you're going to do is you're going to find the charge of the cation and you're going to find the charge of the anion. And when you find the charge of both of them, you're going to make sure that all of the charges are canceling out overall. So again, I'm going to show you the longer method first. And then after I show you the longer method, then I will kind of show you the shortcut for swap and drop. So with this one, you don't always have to draw it like this. Really, you just need the oxidation numbers. So let's say that we have something like beryllium. Beryllium has a positive 2 charge. And we're going to pair it up today with fluorine. Fluorine down here is a halogen. It has a negative 1 charge. So with my beryllium with a +2 and fluorine with a negative 1, when these two come together, you have to cancel out the overall charge. So beryllium on my cation side has a +2 charge. Fluorine has a negative 1. I need to add more negative charges in order to get this to cancel. I have to choose fluorine because that's what I'm dealing with is beryllium and fluorine. You cannot change it into something else. So I'm going to add another fluorine to that. When I add another fluorine, now my total negative charge is -2. So when I go to write this formula, you would have Be, there's only one of them, F2. I'm canceling charges. To show you another one, like, how about aluminum? Aluminum has a +3 charge, lives in group 13. And I'm going to pair it up with sulfur. Sulfur has a -2. I need to make sure that my charges are the same on both sides. Right now, I need to add more sulfur because there's less negative charge than positive. So I'm going to add another sulfur. That gives me a -4 charge. I only have a +3 charge here. So I'm going to add another aluminum. That's +3. So now I have +6 on this side. I have -4 on this side. If I add another sulfur, that gives me +6 and -6. All the charges are canceling. So when I go to write this formula, it's Al, and there's 1, 2 of them, S3. When you're looking at both of these, if you notice, the charges disappear because they are canceling out. So when I'm writing my formula, it's just BeF2. That +2 in the 2 -1s are going away because overall these things are neutral. Same thing here. I have the +3 is gone. My -2 is gone because everything is canceling out. Now this one I just needed 1 and 1. So when I go to write this formula, it just took 1 lithium and it took 1 chlorine. Again, there's no negative charges, there's no positive charges. Now the shortcut version to this is called swap and drop. And when we look at our swap and drop, what we're going to do is we're going to find the charge of the cation, the charge of the anion. We're going to swap the charges and drop them down. And then we have to reduce it if we can because it's the shortcut method, and sometimes that's necessary. And I'll show you an example of that. So on the next slide here, it's kind of hard to read with these boxes. I didn't think about that, sorry. But with the examples that I have here, there we go, that's a little bit easier to see. You have Al with a +3 charge, O with a -2. That looks very similar to the sulfur one that we just did. So when we swap and drop, the plus and the minus disappear because they're not going to drop down to the basement anyway. So you get rid of the positive, you get rid of the negative, and you swap it and drop it to the bottom. 2, swap it and drop it to the bottom. So then your formula is Al2O3. Now this is an example of where you had to reduce it down. Calcium and oxygen have the same charge. If they have the same charge, they are canceling out completely. And so when it had a 2 and a 2, we had to simplify it or reduce it. So that just made it CaO. If you wrote it Ca2O2, that would be wrong. You have to simplify it or reduce it down. Now this one, you have a 4 and a 2 for your charges that you're going to swap and drop. So the 4 came over here to your oxygen, the 2 came over here to your lead. But 2 and 4 are both divisible by the same number. So 2 divided by 2 is 1. 4 divided by 2 is 2. So that's how they got PbO2. So with your swap and drop, I have a few examples that we're going to do. With these examples, I printed them out and I have my periodic table here. So I'm going to again switch over to my camera and we're going to do these examples. Some of these have polyatomic ions in them. Some of them do not. But this one, you have K and Br. K is potassium, Br is bromine. Potassium lives right here. It has a +1 charge. You always write this cation first and then your anion. So you always put your positive charge first and then your negative charge. I always tell people you always give positive news first and then your negative, so use that here. So we have potassium with a +1. Bromine is down here in the halogens, so it's going to have a -1. So with this one, the plus and the minus disappear. There's no numbers left because they're both 1s. So you swap and drop your 1s, so that just makes KBr. The 1 came over here, the 1 came over here. Now on the next one, you see a polyatomic ion. I gave you PO4 is called phosphate. Or PO4 I gave you is phosphate, I gave you is PO4. Sorry, I kept saying that backwards. So it's helpful to put these in parentheses at the beginning. If you always write these in parentheses, I am perfectly fine with that. It's better to have them and not have necessary than to not have parentheses and have it wrong. Now calcium on the periodic table lives in group number 2, so it has a +2 charge. So when I go to write this out for my swap and drop, you have Ca +2, PO4 -3. Again, the plus and the minus disappear. The 2 swaps over here outside of the parentheses. The 3 swaps over here to make it Ca3, PO42. On the next one, I have P and Rb. P is right here, it's phosphorus. Phosphorus has a -3 charge. That one's going to have to go second. You always put your positive charge first and then your negative. Rb is rubidium. Rubidium lives in group number 1, so it's right there. So when I go to swap and drop these, I have to put the Rb, rubidium, first, phosphorus second. Again, your plus and your minus disappear. The 1 drops over there, the 3 drops over there, so you make it Rb3P. The next one, you have Mg and S. Mg is magnesium. Magnesium lives in group number 2, so it has a +2 charge. And then S down here is sulfur. Sulfur has a -2. Those numbers are identical. When the oxidation numbers are the same, they're both going to just cancel out. They're going to disappear. So with this one, it only takes one of each one. It's just MgS. So if you wrote it out and you had Mg2S2, we would have to reduce this or simplify it down. 2 divided by 2, 2 divided by 2 is 1. And then this one, you have Si. Si is right here. Silicon has a -4 charge. It's a non-metal, so it's -4. Strontium is +2. Again, we're going to have to flip these to make sure they're written the right way. So Sr +2, Si -4. When I go to swap and drop, the plus and the minus disappear. The 2 drops over here, the 4 goes over here. So you have Sr4, Si2. Those numbers can get reduced down. You have a 4 and a 2. So if we need to reduce it down, this 4 divided by 2 is 2. 2 divided by 2 is 1. So you'd have Sr2Si. Now I do want to do one more that's not on here. One that has a polyatomic ion, just to show you what I meant when you said that you cannot change what you have. So let's say that we have, how about sodium that has a +1, and you have sulfate, which is SO4 -2. So if I have these two, the plus and the minus are going to disappear. This 2 drops over here. How this actually gets written is Na2SO4. And when you look at this, when you first see them, you're like, oh my gosh, a 2 and a 4, I need to reduce that down. You cannot reduce that 4 because that 4 is locked in to the polyatomic ion. So you actually only have one of those SO4s. So you can't reduce or simplify the 2 and the 1. So this is where it's helpful to always put parentheses around your polyatomic ions, especially in the beginning when you're getting used to seeing these a lot, just so you know that you cannot take away that 4. If you did that and you wrote down like NaSO2, that's a completely different compound and that is wrong. So you cannot do that. The correct answer is right there. So with your swap and drop, you're going to find your charge. Your charge comes from the periodic table for right now or from the Roman numerals if Roman numerals are given. Once you find your oxidation number or your charge, you take away the plus or the minus, and then you swap it and you crisscross it, and you drop it to the basement. You have to simplify it down if you can. Otherwise, the swap and drop method is the most convenient way of writing out ionic compounds.